Equipment used for measuring the cooling characteristics of quenchants in the heat treatment industry is the inconel quench probe defined under ASTM D 6200 and ISO 9950. The inconel probe can be used for comparing quenchants only under laboratory conditions. It is common knowledge that quenchants behave differently when agitated, as it is the case in the plant. The cooling behavior of a quenchant is also affected by contamination, oxidation, turbidity, etc. The reference quench probe was developed to assess the suitability of a quenchant for a specific grade of steel under plant conditions. It uses a specimen of the same grade of steel as being quenched and is designed specifically for use with inverse solver. When deployed in the plant, a reference quench probe outputs the heat flux at the surface of the specimen, the maximum cooling rate at the surface, microstructure and hardness variation from the surface to the core. The reference quench probe combined with inverse solver can thus be used for measuring the cooling characteristics of quenchants under the exact plant conditions, taking into account all the variables affecting heat treatment of a component. Presently, the reference quench probe is a simple handheld unit with the sensor attached at one end and the data logger housed in the other end. Along with the furnace, it can be deployed near the quench tank and the data collected for further analysis. The equipment is being robotized with automated heating, quenching and data transmission in accordance with the modern trend in digital manufacturing. We will now give a couple of illustrations on the use of reference quench probe. The slide shows the results obtained by quenching a 25 mm diameter 100 CR6 grade steel specimen attached to the reference quench probe in two oils. The graphs show clearly that oil A has a maximum heat flux of 1.1 megawatt per meter square at 700 degrees centigrade, while oil B showed a maximum heat flux of 1.6 megawatt per meter square at around 645 degrees. As the success of heat treatment depends on achieving adequate cooling rates at the right temperature, such plant data is expected to give proper guidance in the selection of quenchants. Inverse solver can be used in all cases where process is inaccessible for direct measurement, for the estimation of metal mold heat transfer for casting simulation, efficient design of water or spray cooling systems, selection of mold coat material and thickness in die casting for increased die life, measurement of contact conductance across metallic or non-metallic contacts, measurement of heat flux in all types of welding, friction welding, etc. for quality control, modeling heat transfer coefficient in boiling, condensation, radiation, forced convection, in space technology for design of heat shields and the like, in nuclear technology for design of complex cooling systems. Inverse solver coupled with the newly designed tool reference quench probe can be used for in situ determination of cooling characteristics of quenchants of all types.